Here we go, Algebra 2 students. Welcome back to another Regents review video. This is the Algebra 2 Common Core exam for January 2017. So this video is going to be a little bit longer than usual. These are going to be the solutions to part 1. Is it part 1? No, part 2. Parts 2 through 4. I'm sorry, I don't know what's wrong with my brain today. We are doing the part 2s, 3s, and 4s, the short answer section of this exam. And I know that I show the most amount of work, so therefore you are not cheating off of this video because it's a stupid idea. These part 2s are pretty challenging, so make sure that you try the problems first, then you come here. Hit that subscribe button down below, consider becoming a patron on my Patreon page, and visit my website at www.nysmathregionsprep.com. Both of those links can be found in the description below. And I use the TI Inspire CX calculator heavily in this course. Make sure that you buy one. The link is on my website. Links you right to Amazon or Texas Instruments page. Without further ado, let's begin the part 2s, 3s, and 4s because I want to get this done quickly because this is going to be a long video. But I want to make sure that, I explain it well. Here we go. Express 1 minus I to the third in a plus bi form. So, what you need to know by now is if you raise something to a second, a third, a fourth power, you could write it that many times. So 1 minus I to the third is 1 minus I, 1 minus I, 1 minus I. But the problem is this. You cannot triple distribute. I've never heard of such a thing before. You need to FOIL one of these two first, then distribute at the end. So I'm going to FOIL the first two, first, outer, inner, last. 1 times 1 is 1. 1 times negative I is negative I. Negative I times 1 is negative I. Negative I times negative I is positive I squared. Multiplied by 1 minus I. This is 1 minus 2I plus I squared. 1 minus I. Okay? So now what we're going to do is we are going to distribute this time around. Because now we're not doing triple distribution. Now we're just distributing a binomial to a trinomial. Okay? So, this will give you... Let's see here. Actually, you know what? Wait a minute. Even before that, there's something easier. Hold on a second. I squared is negative 1. So this is 1 minus 2I minus 1. 1 minus I. Doesn't the positive 1 and the negative 1 cancel in this parenthesis? Yeah, it does. So we could take negative 2I multiplied by 1 minus I. Oh, that's so much easier, is it not? And distribute. Negative 2I times 1 is negative 2I. Negative 2I times negative I is positive 2I squared. But remember, I squared is still negative 1. So this is going to be negative 2I minus 2. But they want it, remember, in a plus bi form. So you need to put that negative 2 first. Negative 2 plus, or plus a negative, but negative 2 minus 2I. This, ladies and gentlemen, is a plus bi form. You would lose credit if you did not put it in a plus bi form because they specifically said put it in a plus bi form. That's how you do number 25. Here we go. 26. An orange juice processing plant receives a truckload of oranges. The quality control team randomly chooses 3 pails of oranges, each containing 50 oranges from the truckload. Identify the sample and the population of the given scenario. So the sample is the little group, the population is everyone, okay? So the sample, not R, is, the sample is, actually, okay, no, R, because I'm using a plural. The sample are the pails of oranges. Okay, that's the little group, that's 150 oranges, okay? And the population, which is everyone, the population is the truckload of oranges. Who knows how many oranges are in there, but the truckload of oranges. Okay? Now it says down here, state one conclusion that the quality control team could make about the population if 5% of the sample was found to be unsatisfactory. So that means that there could be some dents, there could be some, hopefully no molds, but maybe some divots, holes, whatever it is. Well, if 5% of the sample is unsatisfactory, then it could be concluded that 5% of the entire population is unsatisfactory. So, it could be concluded that if 5% of the sample was found unsatisfactory, then 5% of the entire population of oranges will be found unsatisfactory. Okay? That's it. Easy peasy. Nice easy part 2. So you just have to know how sample size is related to the population. If you have a sample and 5% of it is this, then the whole population would be that effect as well. Number 27, using the unit circle below, explain why cosecant of theta equals 1 over y. You should know, ladies and gentlemen, that cosecant of theta is the same thing as saying 1 over the sine of theta. And you should know from your unit circle that sine of theta is another way to write y, okay? So here we go. This one did have to take a little bit of knowledge of trig to explain yourself fairly clearly. So I'm going to say cosecant theta equals 1 over the sine of theta. Since they are reciprocal, I'm going to say a reciprocal identity. So you can say reciprocal identity or function. Okay? Sine of theta on the unit circle represents all y values. Since the sine of theta equals y, and cosecant of theta equals 1 over the sine of theta, it can be concluded that cosecant of theta is equal to 1 over y by substituting y for sine of theta in the denominator. And that's it, ladies and gentlemen. That's how you get that question right. Not too bad. You just have to know that your sine values are y. Moving on to number 28. The function m of t represents the mass of radium over time t in years. Determine if the function m of t represents growth or decay and explain your reasoning. So we're really looking at this exponent, folks. If this exponent is a negative number, then it's decay. If it's a positive number, it's growth. Well, if you type this into your calculator, nope, not the graph, calculator, control division, the natural log of 0.5 or 1/2 divided by 1590, negative number, decay. So we're going to say that m of t represents decay because the exponent, that's an ugly x, because the exponent of the natural log of 1/2 divided by 1590 is a negative number. That's it. That's all you have to say. Pretty simple stuff, right? Not too bad. Moving on to number 29. On the grid below, sketch a cubic polynomial whose zeros are 1, 3, and -2. So, yeah, all you're doing is you're drawing yourself an x and y axis. X-axis, y-axis. And if the zeros are 1, 3, and -2, well, that just means x equals 1, x equals 3, and x equals -2. So go ahead and graph it. 1, 3, -2. and this is a cubic function. So it's a cubic polynomial, and the leading coefficient, do we know for sure it's positive? Yes, it's positive, because if you were to distribute everything, because the factors are x minus 1, x minus 3, x plus 2, all of your x cubed terms are going to be positive, so it has to be looking something like this. Just a simple sketch, doesn't matter. And that's it. There's your cubic polynomial. That's an easy question. You're done. Moving on to number 30. Given the equal terms, the cube root of x to the 5th and y equals 5/6, determine and state y in terms of x. So you need to find y in terms of x. Here we go. Since these two things are completely different from each other, because this is a radical, that's an exponent, I'm going to convert this into a rational exponent. Remember that 5 represents your power, okay, and that 3 represents your root. So this is really x to the 5th power divided by 3, and we're going to set it equal to y to the 5/6. Why? Because they tell us that they're equal terms. So now we're going to solve for y in terms of x. So what you need to do is you need to multiply the reciprocal of this, which is 6/5, because we just want y, okay? So we're going to multiply by the reciprocal, 6/5. Those cancel. We get y equals. Now, 5/3 times 6/5 is x to the 30th divided by the 15th. So all you do is just to simplify that number. Y equals x squared. Done. Pretty simple. I think that these part 2s are very simple. It really starts to get into like maybe the part 3s where it starts to get a little tricky. Yeah. Number 31. The results of a survey of the student body of Central High School about television viewing preferences are shown below. Are the events student is a male and students prefer reality series independent of each other? Justify your answer. So, we need to use the tests for independence, folks. We need to use it. There's no other way around it. So, what we need to figure out is are the events student is a male and the student prefers the student prefers reality series independent of each other. So, here we go. I'm going to make the student is a male event A, and the student prefers reality series is event B. So here's the thing. The test for independence is as follows. If the probability of event A given B is equal to the probability of A times the probability of B, and these two numbers are equal, then your events are independent of each other. So, here we go. What is the probability of A? What is the probability of being a male? Well, it's 230 out of 490, okay? But the problem is, nope, there's no problem with that. So we got 230 out of 490, okay? So that's the probability of being a male. And the probability of a student prefers a reality series. Well, a reality series is 180 people out of the total amount of 490. So multiplied by 180 over 490, okay? Now, the probability of A given B, is 70 out of 490. Okay, so the probability of A given B is 70 out of 490. Well, how did I get that, peoples? Well, I'll tell you. The probability of being a male, given that they like a reality series, there's 70 people there, and it's out of the total amount of people of 490. Okay, that's how we got that number. Well, are those two things equal? Let's go to our calculator. Okay, so we get 70 over 490. Is that equal to 180 divided by 490 times 230 out of 490? Your answer is false. So therefore, if this is false, that totally craps out. If this is false, then these events are not independent of each other. So we're going to say no. Because it says they asked the question, are the events independent? So we're going to say no. These events are not independent of each other. I knew that was going to happen. Hold on one second. Are not independent of each other. There we go. And it says justify your answer. When it says justification, they want to see some sort of math. Ladies and gentlemen, this is my justification right there. So we're good to go. Number 32. Given f of x equals 3x squared plus 7x minus 20 and g of x equals x minus 2, state the quotient and remainder of f of x divided by g of x in the form of q of x equals r of x. No, sorry, q of x plus r of x over g of x. So if you don't know what this is by now, oh God, you haven't been studying my review packet, have you? Shame on you. This is the division algorithm. This is the division algorithm, which states if you divide the f of x divided by g of x, you get the quotient plus the remainder over the divisor. Let's do it. So I'm actually just going to write this down for those of you who forgot. Q of x means quotient. R of x means the remainder. And the g of x represents the divisor. Okay? So we actually need to perform this. We got to find this. We have to perform synthetic division. So I'm going to take the denominator, and I'm going to set it equal to 0. So x minus 2 equals 0. I'm going to add that 2 on both sides, and we get x equals 2. Okay? So we take the 2, we put it in our little window, and we take the coefficients of this polynomial. So we got 3, 7, negative 20. Okay? Draw yourself some lines. Draw a line right before the end, and draw a line underneath. Bring down that 3. Get ready to perform synthetic division. 3 times 2 is 6. Add these up, you get 13. 3 times 2 is 26. Add them up, you get 6. Okay, so your quotient, and remember, when you synthetically divide, your degrees drop by 1. So we get 3x plus 13 plus the remainder over the divisor. Ladies and gentlemen, that is the answer to that question. 3x plus 13 plus 6 over x minus 2 for, if I get it right, for that question. All right, not too bad. It's on almost every exam. I highly suggest that you remember how to do those. Fair? Good. 33, we're almost done. Almost done, peoples. Doing good so far. All right, I keep doing that. Okay, this one, okay, so I remember tutoring a couple kids last year, the year before, over the course of however long this exam has been out for, and many people had difficulty with this. Honestly, this has to be the easiest question I've seen ever as a part 3. It's not too bad. And if you're having trouble with it, I'm going to make it easy for you. Algebraically determine the values of h and k to correctly complete the identity stated below. When it says identity, it means that these two things are equal to each other. So what your job is to simplify this as much as possible. This is already simplified. Your job is to simplify this over here, okay? So we get 2x cubed minus 10x squared. I'm just rewriting what's on the left-hand side here. I'm going to set it equal to this. Now, your job is to distribute all of this. It takes a little bit of time, but you could do it, I promise. So x times 2x squared is 2x to the third. X times hx is plus hx squared, okay? X times 3 is 3x. Negative 4 times 2x squared is minus 8x squared. Negative 4 times hx is minus 4hx. And negative 4 times 3 is negative 12. So now your job is to do the following. Your job is to combine like terms. Combine like terms. So some like terms here are the following. Actually, you know what? Let me do this for you. You see how on the left-hand side this is a constant, it's just a number. On the right, oh, I forgot to add that plus k at the end. My apologies. Okay? That's a constant. -7. The constant over here, which is -12 plus k, has to equal -7. Well, to solve for the value of k, it's -7 must equal -12 plus k. Add that 12 on both sides. What does k have to be? K must equal the number 5, because k is a constant. So we just found our constant, k equals 5. Now let's find the value of h, right? So h, in this case, we have, so h is attached to a quadratic term over here. So we got a quadratic term, quadratic term, quadratic term. So take a look here. Take a look at the coefficients. We have a -10 in h and an 8. We need -10 to equal h minus 8, okay? Because we don't know what h is yet. So I am going to add the 8. Your h has to equal -2. That's it. And if you just want to check, substitute it back in, you get the right answer, okay? So these are your values, folks. K equals 5 and h equals -2. I honestly think that was a good question. Not too bad. Don't overthink it, please. All right, moving on to number 34. Elena has decided to run the Buffalo Half Marathon in May. She researched training plans on the internet and is looking for 2 possible plans. Jillian's 12-week plan and Josh's 14-week plan. The number of miles run per week for each plan is plotted below. Which one of the plans follows an arithmetic pattern? Explain how you arrived at your answer. Okay. Arithmetic means that there is a common difference. Okay, there's no jumping. There's no jumping on the graph. Obviously, Josh's plan is not arithmetic. It's jumping all over the place. Jillian's plan is arithmetic. Yeah. It's going up in a linear fashion. So we're going to say that Jillian's plan follows an arithmetic pattern. Because it increases at a constant rate. Okay? And you could even say that the distance increases by 1 mile each week. That's how you know it's arithmetic. Done. That's how you do that question. Nice, easy question. Should have gotten those 2 points and ran with it. Now for the next one, write a recursive definition to represent the number of miles run each week for the duration of the plan you chose. So we got to write a Jillian's plan as an arithmetic sequence. So the first term, ladies and gentlemen, the first term is 10 and it's increasing by 1. So recursion, we have to say that the first term is 10 and a sub n is equal to a sub n plus 1. What did I just write here? Now that plus 1 is not in the subscript. It's a big one. It's a big 1. I'm going to make that n a little bit smaller. So what I just said was the first term is 10, and this is telling you that each additional week after the first, you're adding on an additional mile. Okay? So this, ladies and gentlemen, is your answer. Then, for this next part, it says, Jillian's plan has an alternative if Elena wanted to train instead of for a full 26-mile marathon. Okay, now she wants to do a full marathon, not a half marathon. Week 1 would start at 13 miles and follow the same pattern for the half marathon, but it would continue for 14 weeks. Write an explicit formula in simplest form to represent the number of miles each week for the full marathon training plan. So, the explicit formula for an arithmetic sequence is a sub n equals a sub 1 plus n minus 1 times the common difference of d. So, she starts off with 13 miles now. So that's a sub 1. A sub n is equal to 13 miles. Plus, we don't know the n minus 1. And we do know that the common difference, it says here, but would continue the same pattern. She's still increasing by 1 mile. So a sub n is equal to 13 plus n minus 1. Your answer is n plus 12. That's it. That is the simplest form of the explicit formula to represent this new training plan. All right, moving on to number 35. The guidance department has reported that of the senior class, 2.3% are members of the Key Club, K, 8.6% are enrolled in AP Physics, P, and 1.9% are in both. Determine the probability of P given K to the nearest 10th of a percent. So, here we go. The probability of P given K is given by the formula, the probability of P given K, the probability of P intersection K divided by P of K. Okay? So, the probability of the intersection of both, intersection means that they're in both groups, is 1.9%. Okay? Divided by the probability of enrolled in Key Club is 2.3%. When you divide those two numbers, you get 82.6%. That's it. That's your answer. Now, let's just say you don't like what I just did and you like it visually. I highly recommend visual. That's perfectly fine. So, I'm going to make this red circle. I'm going to make that Key Club. And I'm going to make this blue circle physics. Okay? So, this is the Key Club. And this is physics. So, there is, so this is really just the same as the top. So, there's let's see here. There's 0.4% in Key Club. There's 6.7% in physics. And there's 1.9% in enrolled in both. All I did to get these things on the outside is just subtract from the original what they gave, okay? So this is just the same thing as the top. The probability of P given K is equal to the probability of what is given at the top. So that is just a little figure just in case you wanted to see what was going on there. It's still 82.6%. Now, it says the principal would like a basic interpretation of these results because he's not good at math. Write a statement relating to your calculated probabilities to student enrollment in the given situation. Basically, you're just saying that a Key Club member has an 82.6% probability of being enrolled in AP Physics. That's it. Done. All right, moving on to the last part 3, then we're moving on to the part 4. Using the formula below, determine the monthly payment of a 5-year car loan with a monthly percentage rate of 0.625% for a car with an original cost of $21,000 and a $1,000 down payment to the nearest cent. Okay, let's talk about this for a second. First of all, whoever bought this vehicle put down a $1,000 payment. So let's figure out what P of N represents. P of N represents the present amount borrowed. You did not borrow $21,000, ladies and gentlemen. You did not. You borrowed this. You borrowed $20,000 because you already put down the $1,000 payment, okay? So N, which is the number of monthly pay periods, let's see here. It's a 5-year car loan with a monthly percentage rate. So it says monthly percent. You need to make sure that your N is in months. So it's 5 years times 12 months in a year. That's equal to 60 months. That's your N value. Okay? Your PMT, which is the original... No, I'm sorry. No, your PMT, which is your monthly payment. That's what we're trying to find. Determine the monthly payment. That's what we're trying to find. That's your question mark. And your I, the little I, the interest rate per month, that is 0.00625. Remember, you got to take that percent and put it as a decimal, 0.00625. Okay, so we're going to take all this information and we're going to plug it in. So we get 20,000 equals, I'm gonna call PMT, I'm gonna call that X just because I don't want to write PMT. So X times 1 minus when parentheses 1 plus I, which is 0.00625, raised to the negative 60th power divided by 0.00625. That's a lot of stuff. So now what I'm going to do to solve for x is I'm actually just dividing by this whole thing. I'm dividing by 1 minus 1 plus 0.00625 raised to the negative 60th power divided by 0.00625. And I'm dividing it the same thing over here. 1 minus 1 plus 0.00. Oh my god, are they nuts for making you write this all? It's a lot. Cancel all those out and we get x is equal to, I'm going to plug that into my calculator. This is going to take a little bit, even though that I have the answer right in front of me, but I just want you to understand what it will look like. Parentheses 1 minus parenthesis 1 plus 0.00625 raised to the negative 60th divided by 0.00625. Enter 400.76. So the monthly payment to the nearest cent, $400.76. That's it. Done with that part. Now we got to move on to the other part. The other part says the affordable monthly payment is $300 for the same time period. Determine an appropriate down payment to the nearest dollar. So basically they're telling you now, and they decided to do this to you, they decided, hey, let's now make the PMT $300 a month because that is the car dealership. Now, look, the car dealership will never say this to you. Like, oh, yeah, just pay $300. No, they'll make you pay $400. They don't care. But this particular car dealership is a family-run business. They're like, no, $300 is enough to pay it off. So now what we need to do is find the down payment. Well, the down payments, this is tricky here, folks. And I hope that this makes sense to you. P of n represents the present amount borrowed. So your new present amount borrowed is $21,000 minus y, where y is the amount of money borrowed. I don't know how much they borrowed. So therefore, we have to substitute in for y. So $21,000, which is the original price of the car, minus the down payment that they make. That equals the monthly payment that they want, which is $300, times 1 minus 1 plus 0.00625 raised to the negative 60th divided by 0.00625. Okay, now let's go ahead and solve for y. So what you got to do is this. This is just one big number. I know it doesn't look like it, but that's just one big number. There's no variables here. Just subtract the 21,000 on both sides. Those cancel. You get negative y is equal to, I'm going to tell you what this number is. That is negative 6,028.408. Divide by negative 1. Divide by negative 1. And you get the appropriate down payment is $6,028 when it's rounded to the nearest dollar. That is how you complete that question. That was weird. I think a power surge just happened. My apologies. That certainly frightened me a little bit. Anyway, moving on to part 4. There's actually a rainstorm going on right now. Probably a little windy outside. Number 37, the speed of a tidal wave S in hundreds of miles per hour can be modeled by the equation S equals the square root of t minus 2t plus 6, where t represents the time from its origin in hours. Algebraically determine the time when S is equal to 0. So what we're going to do is this. We're just going to take this whole thing, and we're going to set it equal to 0. Pretty simple stuff, right? The square root of t minus 2t plus 6, set it equal to 0. Let's do it. So I'm going to add that 2t and subtract the 6. Add the 2t and subtract the 6. We get the square root of t is equal to 2t minus 6. Now, the reason why I isolated that square root of t is you need to square both sides of that, okay? So once we square it, because we need to solve for t, square it, we get t equals 2t minus 6, 2t minus 6. Okay? Now, let's see here. I'm going to distribute this. So we get t equals 4t squared minus 12t minus 12t plus 36. Okay, not too bad. Move the t to one side. We get 4t squared minus 25t plus 36 equals 0. So now what we're going to do is we got to factor this now. But the problem is we need to apply the AC method of factoring. Remember that back in Algebra 1, you had to take the first term and multiply it to the last term? Yeah, we need to do that again. So t squared minus 25t plus 144 equals 0. Let's go ahead and factor this now by the AM method. What adds to negative 25 and multiplies to give you 114? So that gives us t minus 9, t minus 16 equals 0. But remember, ladies and gentlemen, once you perform that operation with the AC factoring, you need to still divide by the leading coefficient. Okay? So what happens here is this. If you're dividing by the leading coefficient and you get a fraction that can't be simplified any further, you take that number and you move it up. So you get 4t minus 9, and this could simplify nicely. We get t minus 4 equals 0. T-bar it. We get 4t equals 9, divide by the 4 on both sides, and you get time t equals 9/4. And over here, this is t is equal to 4. Let me just double check that. Now, here's the thing. We need to check both of these. We need to check 9/4, and we need to check t equals 4. I could tell you this. If you take t equals, oops, I'm going to pick a different color. If you pick t equals 9/4, the square root of 9/4 minus 2 times 9/4 plus 6 is equal to 3. 0 does not equal 3, ladies and gentlemen. So that actually rejects. You are keeping the t equals 4. You're keeping that. T equals 4. That, ladies and gentlemen, is how you do that question. Okay? Now, for the very last part, how much faster did the tidal wave traveling after 1 hour and 3 hours to the nearest mile per hour justify your answer? So, what we need to do is figure out the 1 to 3 hours. So, you're literally plugging in t equals 1 and t equals 3 into your original equation. Okay, let's do it. So, the square root of 1 minus 2 times 1 plus 6, that will give you a total of 5. Over here, this will give you the square root of 3 minus 2 times 3 plus 6. That will give you the square root of 3 minus 6 plus 6. Those 6's cancel. We get the square root of 3. So now, how much faster did the tidal wave go? It was 5 minus the square root of 3. Okay. That number, when you type it into your calculator, you get 3.268. And remember here, this is in hundreds of miles per hour. Here's why. If you go back to the original piece, it said the speed of the tidal wave in hundreds of miles per hour. Now they're asking you to the nearest mile per hour. So what you got to do is take this number, which is in hundreds of miles per hour, and multiply by 100. Okay? Because it's in hundreds. 100 multiplied by 100. You get 327 miles per hour when you round it off. And that, ladies and gentlemen, is how you do that last question. I hope that this was helpful. Make sure to hit that subscribe button down below. Consider becoming a patron on my Patreon page. I would greatly appreciate it. And make sure that you visit my website at www.nysmathregionsprep.com. And I hope to see you soon.